Hello everyone, today we will solve a resultant problem. Here the problem states, in figure 9 let F is equal to 3600 pound and theta equals 45 degree. Assume both pulleys to have no friction so that the tension in the cable CD is 3600 pound. A. Solve graphically for the force on the shaft at B. B. Solve graphically for the force on the bearing at A. Check each solution algebraically. So, for the A, we will have to find the resultant force in the B shaft. So, if we draw the FBD or the free body diagram of the B shaft, we would find something like this. Here, this would be the theta, and in the problem it says theta equals 45 degree. So we get this as 45 degree. Let's say F is equal to F1, which is, in the question it says 3600 pound. So we will write it as 3600 pound. And then the tension in the cable, which is CD, here in the question it says 3600 pound also. So we will write it down here as 3600 pound. So if we think the angle between F1 and F2, we get alpha, which would be 90 plus 45 equals 135 degree. So we can write here alpha equals 45 plus 90 degree. Then we can write it down as 135 degree. So the resultant force would be somewhere in between them. So let's find it out. For the magnitude of the resultant, we will use the formula of R equal root over F1 square plus F2 square plus 2 into F1 into F2 cos alpha. Let's apply the values here. Then we get 3600 square plus 3600 square plus 2 into 3600 into 3600 cos 135. So we can now calculate it. We get square plus 2 into 3600 into 3600 into cos 135. Then we get something like this, and then root over answer we get 2755.32 pound. That would be the magnitude of the resultant which is acting on the shaft B. Now if you want to find the angle of it, then we will have to do tan theta equals F2 sine alpha divided by f1 plus f2 cos alpha. And if we put the values in, then we get theta equals tan inverse 3600 sine 135 divided by 3600 plus 3600 cos 135. And then if we calculate it, we will find the value of theta. So then if we try it here, we get 3600 sine 135 divided by 3600 plus 3600 into cos 135. Then we get something like this. Then we will use tan inverse answer, and that would be 67.5 degree. 67.5 degree, which would be from the f1 portion. So somewhere along this here we will get 67.5 degree. So if we think of it from the first quadrant, then we can write it down as 270 degree minus 67.5. We get 202.5 degree. Or we can write it down as 202.5 degree. That would be for the first one. And if we solve the problem B, there we will have to do the math for the A shaft or the A bearing. So let's do just that. For that, we will draw a free body diagram. Here we will draw it for the A part. So that would be something like this. And since we can see in the previous one that the angle with the second shaft and the cable, here we have theta degree, so we will also get a theta degree in here. So we can say that the angle here would be theta. And from the question we know theta equals 45 degree, I guess. Yes, 45 degree. 45 degree. And if we take it as f1 and this as f2, then we get 3600 pound, and this was 5000 pound. So this would be the angle alpha. And here if we want to find the value of alpha angle, we will have to do it this way: 90 minus 45, which is 45 degree. Then we will find the magnitude of the resultant and use the formula R equals root over f1 square plus f2 square plus 2 into f1 into f2 cos alpha. And if we then put the values here, we get f1 which is 5000 square plus f2 square which would be 3600 square plus 2 into 5000 into 3600 into cos 45 degree. And if we calculate it, then we get 5000 square plus 3600 square plus 2 into 5000 into 3600 into cos 45. Then root over answer. We get 7963. 7963.41 because we have 406, so we can take it as 41 pound, and the magnitude would be theta equals tan inverse f2 sin alpha divided by f1 plus f2 into cos alpha. Then we can write it down as tan inverse f2 which was 3600 sin 45 degree, and then f1 which is 5000 plus 3600 cos 45 degree. Then we get 3600 sin 45 divided by 5000 plus 3600 cos 45. Then tan inverse answer, we get 18.64 degree. 18.64 degree. So it would be from the vertical axis this angle would be the theta and the total would be alpha. So we get 18.64 degree from the vertical axis. So if we calculate it from the first quadrant, then we get 18.64 plus 270 degree. We get 288.64, or we can write 288.64 degree. So that's it for this math. Thanks for watching.